All right, music's going down. Looks like we're ready to begin. We got our slides going. It's 5:40, last session of the day. Hopefully everybody's brain is already full of knowledge juice at this point. We're going to take a deeper look at Blazor today. My name is Ryan Nowak. I'm a developer and architect on ASP.NET Core, and this is...
Hello, I'm Steve Sanderson. I'm also, same kind of thing as Ryan. We've been working together for how long now?
A year and a half, 3 or 4 years? Same thing.
Something in that quite wide range, yeah.
So engineer number 1 and engineer number 2 on Blazor up here. So agenda, today what are we going to do? I'm going to have a short presentation about Blazor Server. We're going to talk about how that works and lots of juicy details about that. A lot of that information applies to Blazor Client as well, but since we just shipped Blazor Server, I'm mostly going to be talking about that. And Steve is going to show us.
Yeah, I'm going to give you some more advanced demos about some things relating to authorization and authentication, which we don't normally get to talk about.
Yeah. So all of the content today is going to be slightly on the advanced side. So if you're here, hopefully you've heard of Blazor so far. This is not going to be an introductory talk. This is going to be some more deep, technical, in-depth content. And hopefully that is useful to you, or at least entertaining for you. I think there's lots of cool technical stuff to learn about here. So let's get started. So Blazor Server, how does it work? Today what we're going to talk about with respect to Blazor Server is sort of a progression of from the point where you write your code to the point where the DOM is updating in the UI. How does that process work? In addition, what's going to fall out of that is some information about Blazor performance and the design of how the Blazor rendering process works, as well as how to think about the scale of Blazor Server in production. And this is a deep dive, to be totally clear, into details that you don't really need to know. So not an introductory course, not necessarily a deep reflection of how to program Blazor or best practices for architecture. But if you're the kind of person who likes really detailed information and you like to know all the low-level secret details, this might be useful to you and it might help you understand and get a better appreciation for what's in Blazor. And hopefully it's still fun for everybody and you can learn something and tickle that part of your brain. So at a high level, how does Blazor Server work? You write C# and/or Razor code. It runs on the server in a .NET Core process. So remember, Blazor Server is not the WebAssembly flavor of Blazor. It's the .NET Core flavor of Blazor. And then that rendering process, that Blazor process, your application running in a .NET Core process, is going to update the UI in a browser somewhere else on the internet. Ooh. We do that via SignalR, usually over a WebSocket connection. So we can send UI updates from your server to somebody sitting in their house or on their phone or somewhere else. And we're going to look at questions like, how can this work and how can this be done in a performant way? A lot of that information and those sort of motivating design details that make Blazor Server work are true of both WebAssembly and Server. And Blazor Server was something we invented well after we had figured out Blazor WebAssembly. So that's why it has so much in common. And you'll find that a lot of the details that are common to Blazor are pivotal to how this can even work in the server-side model. So if you're the kind of person who likes diagrams, here's a nifty diagram. On the left, we've got our ASP.NET Core process. We've got Blazor running on top of your components, running on top of .NET in .NET Core 3.0. And you've got the SignalR communication channel that is talking to a browser somewhere with a DOM. Again, SignalR is that real-time WebSocket-based communication framework. This is how we push DOM updates into a browser, and this is how we get UI updates or UI events from a browser, as well as things like JS interop or any other kinds of things that we need to make Blazor Server work with the browser, all go over that WebSocket channel. So when you're writing your Blazor code, it's going to look something like this, right? We are inside the counter component here, and I have got another component that I'm using here, which I'm calling fancy span, which is a fancy sort of span. And that's basically the only modification that I've made to this from the default template. I'm going to switch to that because I've got that over here and just give that a run for y'all. You can ignore that for now. So I'm going to go to the counter page. I've got this very exciting fancy span here, and when I click the counter, it's going to go back and forth between bold. Wow, that's powerful.
This is revolutionary.
Revolutionary.
From this.
Everyone is going to want apps that are either bold or not. Incredibly valuable. So this is our sort of motivating example for today, and it's not really that impressive or that complicated, and that's great, because it's a great opportunity to dig into these low-level details and see kind of how Blazor works on a fundamental level. There's not a lot of complexity in this sample, which is hopefully going to help everybody sort of understand the principles here. So Blazor, at its core, is based on a bunch of different primitives, and I'm going to kind of flip back and forth between the code and this thing so you can see what those are. So we have primitives in Blazor, like elements. Those are your HTML tags. We have primitives in Blazor like components. That's where you render another component and use its output and compose with it. We have primitives in Blazor like attributes. Attributes can either be parameters that are passed to a component, or they can be attributes on an HTML element. And we also have content, and content is, well, it's content. It's just the raw text output, the things that are going to show up in the DOM as plain text. Now we also have some high-level constructs like events and @bind and @onClick. Generally, most of your high-level constructs in Blazor are going to map to attributes. So there are probably some special cases. There are probably some things that I forgot. If Steve feels like mentioning them, he will. But everything that we're going to look at today, for the most part, either is one of these 4 primitives on the top or maps to an attribute. So if I flip back to this, I can identify some of these things. So up here, we've got an element. Right here, we've got a component. You can tell it's a component because it's uppercase and it's bold. Up here, we've got an attribute. We sort of think about attributes being passed to components and attributes being passed to elements as like really similar things. Here, we've got some content inside of here. And this text that's being evaluated here, or this expression that's being evaluated here, when you see @something, it's C# code that's going to run and produce a value in Blazor. That's actually content too. It's just content that's going to be dynamically computed. Likewise, this C# expression here, these @parentheses thing that's inside of this attribute, is just the value of that attribute. So we've got all these different kinds of primitives that we talked about before. Some things that probably don't fall into that primitive category that are going to be mapped to attributes are like this @onClick attribute here. What is that? So when you see in front of an attribute in Blazor, that's something we refer to as a directive attribute. And there's a couple different categories of those that you'll see. And they all represent like power. Like they're all like some kind of superpower or something like that. So @onClick in this case means this is the C# version of the onClick event handler for this button. Likewise, the fact that we can nest content inside of this fancy span. We put some static text in here. You could put other components in here, other rendering logic in here, and that's like a special kind of value that will be passed to that fancy span. So enough of looking at the code. I promised a deep dive, and deep dive we shall. So what does the compiler do? So a lot of what I spend my time on when I'm working on Blazor is writing this compiler along with some other people on the team and thinking about, well, when you write all that code in that Razor file, what does this turn into? What does it output? What does it do? How does it behave? So the way that .razor files work is they actually get compiled to C#. So all of the expressions that are in your C#, they appear in like special positions in some generated C# file. And then those generated C# files are passed to the compiler along with your other C# files and ultimately make your assembly. So if you inspect this code and you're very careful, you will see those 4 primitives that we talked about here represented. You'll see elements, you'll see content, you'll see attributes, you'll see components. This is a component. And you'll see those 4 primitives show up here, right? Likewise, the content that we passed to that fancy span component is actually represented as an attribute that has a value that contains a .NET Lambda. So that's how composition generally kind of works in Blazor. And at its core, it all just goes back to those 4 primitives. Everything is either elements, components, attributes, or content. So the job of the compiler is basically to understand the code you wrote and turn all of that structure into those 4 primitives. The generated code, when it's executed, which is the thing that we just looked at, is going to produce a data structure that primarily contains those 4 primitives. So if you think about what's going to be in there, it's going to be the fact that it's an element and the element name, the fact that it's a component and the component type, the fact that it's an attribute and its name and value. And we call this process rendering. So if you look at a component class and it's got a build render tree method, or you hear us talking about rendering, rendering is the process of executing all of the code that's in here that's not inside the code block and getting its output. So what does it output? Well, we can look at that too. I captured this data earlier today using Steve's cool unit testing prototype that he showed during his talk. If you're really smart and you feel up to it, you can try just building a component, writing a unit test, and then set a breakpoint inside that renderer, and you can see what the renderer actually works with. So I have simplified things, and I have tried to sort of extract the parts of this that are useful for teaching so that we can look at them. And this is the output of rendering the component that we've been looking at, that counter component and that fancy span, and doing its first render and getting kind of its snapshot. What is all the DOM? What is all of those 4 primitives that we produce from that first render? So you can see we're inside the counter component here on the left. We have some markup. One of the optimizations that we do in Blazor is that when you have elements, attributes, and content that are entirely static within the page, like this H1 banner that contains the text counter, we'll sort of reduce that into a single node for the purposes of optimization, so don't let that throw you. Then you can see we open an element here that's a div. Then you can see we open the fancy span, and so on and so on and so on, and it's all those 4 primitives. On the right-hand side, you see the rendering output of the fancy span. Both of these 2 components produce their own independent sets of frames. So an important takeaway or conclusion from this to understand about how components work is that each component gets its own set of frames, it has its own output, and they're independent and get stitched together later.
Shall we say why it's frames and not a kind of tree structure
Please.
menu? OK, right, so when this stuff is getting rendered, we've got a big array in memory that we can fill up with these render frames. So as we're going through invoking each of these instructions in the render method, that adds a frame into this array, and we keep going through populating that array. Now, that's not the most obvious way to do it. A more obvious way would be to build up a kind of hierarchical tree structure, where every time you open a new element, we'll create an element instance, and then we'll recursively start populating that and build a big recursive data graph in memory. And we could totally have done that, but that wouldn't have performed anywhere near as well, because it would be constantly allocating for every single thing it needs in that tree structure. And so as a pretty important optimization for us, we want rendering to not allocate memory. It should operate over fixed buffers of data, and that's why we've got these arrays of frames that we populate. And it makes things look a lot more complicated, and it is, but you don't have to worry about that for your normal programming tasks.
Yeah. So everything that Steve just mentioned is true, by the way. So render frames are what we call the output of building the rendering tree. It's a declarative format, and the great thing about render frames as a format is it's very efficient, as Steve mentioned, and it's very efficient for doing a bunch of things that we care about. You can very efficiently turn it into HTML in an O of N operation, so a single pass over the frames. And you can very, very efficiently diff outputs of render frames. So if you have 2 sets of render frames that come from the same components, it's designed for diffing. Now, I didn't mention these numbers, and some of you probably wondered what these numbers were. I'm not going to give an extremely detailed explanation of how this works, but the numbers exist as an aid to the diffing system. So they basically, what the numbers map to is the line of code, effectively, the logical line of code that produced this render frame. And the way that that works is when you have conditions in the generated code, or you have conditions in your code, or loops in your code, those sequence numbers will reflect the control flow that took place when you executed the application and will help in diffing. Whew. So in general, why do we care about diffing? We care about diffing because of 2 things. Because in Blazor Server, we're going to send the diffs or send DOM updates over the network. We want it to be the most efficient set of data, the smallest set of data that's necessary to get the output that you want. The other reason why we care about diffing is both for Blazor Server and for Blazor WebAssembly, DOM updates are very comparatively expensive to all the other things that we're doing here. Things like running your rendering method or building the render tree or doing the diff itself are actually fairly cheap compared to doing things like updating the DOM. So we'd like to avoid updating the DOM when necessary. And we'd also like to ensure that we can transmit the minimal amount of information. So I think Steve mentioned a lot of these things already, so I won't go into this. I won't read my own slides at you. But the important part here that I think is to explain in a little bit more detail is what's on the right. So each component has its own set of frames that come out as its output. And just like that, each component is designed to sort of render independently from the rest of the system. So the way that the render infrastructure is designed is we queue up components for rendering. During the rendering process of a component, it might trigger other components to render. And we basically try to find the minimal set that needs to render and execute them in order until there's nothing left. So what causes a component to render? What causes a component to update its state? When I say render, you should think update state, right? When I click that button, something went bold inside the fancy span, and something went bold inside the counter. The kinds of things that make a component render are, first of all, its initial creation. Second of all, when parameters change. Third, when an event happens. And fourth, arbitrary reasons that you decide, the most common one being things like background timers or other kinds of notifications that come from your app code. Ultimately, it's the component that decides when to render itself. If you're using Razor code to author components or you're inheriting from component base, you're getting all these behaviors by default as well. So who renders in our example? I clicked the increment count button, and we saw that the current count changed, which implies that we would need to render this page, the counter page. And we also saw that the fancy span toggles every time you click, from bold to not bold and back and so on. So can we figure out why we render? Well, this component has to render because it handled an event. So we click the onClick button. Increment count is a method on this class, and so we re-render the counter component. Then, when we're re-rendering the counter component, we evaluate this expression. We compare that to the previous value of isBold, and we see that that has changed. And so the fancy span also has to render. So each of these rendering decisions is somewhat independent from each other and tries to be efficient and do the minimal amount of work when necessary. In this case, something we're passing into the fancy span said, hey, you've got to update because the value's different. So how does the diffing work? I'm not going to go in incredible detail about the diffing, how the diffing works. I think Steve might have a few things to say about it.
We've got some awesome documentation for it. It's called the source code. You can go and read that.
Generally, with the diffing code, I have to acknowledge, this is difficult for me. I'm going to take a moment. The bus factor on diffing code is very high. Steve and Javier are, I think, the only people who really understand what's going on there. Okay. Maybe I'm being generous to Javier. Anyway, if Europe sinks into the sea, expect a rewrite of Blazor. Anyway, so what the diffing process basically batches through lists of frames that are known to have come from the same component. And what it outputs is a different set of instructions. So it's a set of instructions to basically turn the current state into the future state. So these are the diff outputs from clicking that button. And we'll do the right side first because it's really simple. The right side produces one diff instruction, not one diff instruction. And it says set attribute. And then it will have a pointer to this frame, and it will say set the style attribute to empty. And that's it. That's the only diff for fancy span. So when we run diffing after doing that click, the only thing we need to do to the DOM is we need to find that attribute, and we need to set its value to 0. Likewise, the counter component is a little bit more complicated. We need to update that count value. Remember, that's content from 0 to 1. And that content is inside of div and p tags. So we have a step in. So we step into a div tag. Then we step in to a p tag. And then we update that text. And then we step out and step out. Now, how does the system know that we're stepping into a p tag? How does the system know that we're stepping into a div tag? Well, remember that output we looked at before, that big honkin' output for counter component? These diff instructions, I'm not showing it to you here, but they have offsets, and they say like, step into the one at offset of 3 or something like that, right? And it ends up being like these diffs are very coupled to exactly what state came before and exactly what state came afterwards. So think about that. I'm not showing all the details here because I don't want to make everybody's heads explode, but I want you to get the point, which is that the system is designed to produce the really minimal set of changes that need to happen. It's fairly sophisticated to guarantee that. And we do that by identifying exactly what parts of the DOM need to change and changing only those parts. At no point do we like generate new HTML and just paste over something. Like we go by manipulating things. So benefits of diffing, it's really cheap. All the stuff that we've talked about here so far that the framework is doing on your behalf is very comparatively inexpensive compared to things like updating the DOM or sending bytes over the network. Components are designed to only render if they have a reason. Usually that's going to just work in your favor, and your components aren't going to do any work if they don't have anything interesting to do. One of the nice side effects of doing diffing is if your component does re-render and it produces the same output, you'll get a 0 diff. So there's nothing to do, and it can short circuit very nicely. And the things that are comparatively expensive in terms of the Blazor UI process are network transmission of DOM updates, which we sort of amortize by batching, and the actual DOM updates themselves are comparatively expensive. So how does the server work? And I'm going to speed up a little bit here because I want to make sure Steve has time to do his demos and cool stuff. And we're also going to leave a little bit of time for questions. So how does this work when we introduce Blazor Server to the mix? Well, rendering with Blazor Server, how we actually apply the updates to the UI, how we run your components, how we figure out what to change in the UI, everything you've heard so far is the same. So the process of how do we figure out what operations to do on the UI, totally the same between WebAssembly and Blazor Server. Adding the server just means that the DOM updates have to go over the wire. So we have to send them over that SignalR connection that we talked about. And we choose SignalR because it's bidirectional, it's got low latency, and it's got a very low amount of overhead per message. In addition to that, we use a message pack format instead of something more verbose like JSON. So we use a very optimized binary format to transform these frames over the wire. I'm going to break from my prepared remarks and just show a quick demo of this in the interest of time. So let's run this up, and I'm going to show you what's happening in the UI here just to sort of prove that that's what's happening. So I've got my counter page here that's very exciting. And I can't zoom in any closer on that, unfortunately. And I'm going to find that area of the DOM. And then I'm going to expand this so you can see our fancy span, and you can see, hopefully the font size is pretty good. It's kind of a challenge to make the font size bigger in the developer tool. So you can see when I click this, it's going to kind of flash on the screen. So you can see Chrome can tell you exactly what changed in the DOM. And it's because we're only changing those parts. Now, the other piece of this that I want to highlight here is I'll refresh this because the network tab always wants you to refresh things. I'll refresh this, and you can see that I've got this WebSocket over here. And I can look at this WebSocket, and I can see all of these messages that are coming through this WebSocket. So you can see we're getting a 243 byte down message, and we're getting a 27 message back, and so on. So when you keep clicking this, you see these messages fly. And they're all sort of on the order of like 200, 250 bytes, something like that. That's the size of that payload that's saying, update this count and set the style attribute to empty. That's what's going over the wire, and that's that 200 bytes. So that's roughly what the message format is like. The message format, because it's based on message pack, which is a binary format, it's not human readable, so we're not really going to look at it. Yeah. As far as how do we do the server-side communication, how does this work? So I can show that as well. When you do a connection and when you browse to that initial page, you get this blob of HTML back that's in part of the page. And this can be whether you're using pre-rendering with Blazor or not. But when we run your server-side code, we say, well, we're going to put the counter component here. We're going to put the app component here. So we generate in a comment in the page this sort of set of instructions for what the server can do. We call this a marker. These markers are encrypted payloads, so it's something that only the server will be able to understand. And really the reason why we have encryption there is to prevent tampering, to prevent you from injecting like sort of garbage data in there. It would be very hard or very impossible for you to brute force this and come up with a data payload that's going to do something different. They're also timestamped, so you can't really replay them beyond like 30 seconds after when it was issued. So then the client opens that WebSocket connection to the server, and it basically sends back this information and says, hey, this is who I am. And it's the full list of instructions of what the server needs to do to get you into this sort of initialized state. So in this case, the instructions go to the server that say, well, my component that is the root component of this app is mysite.app. Go ahead and load that. And that's how the server gets into the same state. And then you're connected and things start working. So how this works, you get a SignalR connection. Over that connection, you get a secret ID. The browser holds on to that secret ID and can use it to reconnect if something goes wrong. And that's important because on the server, we have to retain the ability to diff with the client. So we need a persistent connection to the server because all your state and all your components are in memory. We will hold on to your components in memory on the server until you disconnect and things time out, or until you gracefully close. So if you close the browser tab or if you navigate away from the site, for instance, we'll detect that inside the browser. We'll send a message to the server, and we'll instantly kill all your state on the server. I already showed the client-server communication. Let's actually look at one more thing. So when you're using server-side Blazor, and these are sort of debug level logs, I don't expect anybody to be able to really get what's going on here, but I think maybe if you look carefully, you can see some of the things that we're talking about here. So when I click this button, it sends a SignalR message to the server. That's where my cursor is right now that says, hey, the mouse was clicked here on this button. Then that goes to my event handler. That's event 3. It's mouse event args. And you can see we render the counter. We render the fancy span. We get a batch number 7 of size 217 bytes. And that's sent to the client. And then the client acknowledges the batch and says, hey, I got it. I did the thing. I applied the update. And that's roughly how eventing and communication work in server-side Blazor.
Cool.
Cool. So I think I'm going to wrap there and yield the rest of my time to Steve.
You don't want to do the bandwidth thing?
Oh, we can do the bandwidth thing. So in case you've been curious about performance of SignalR, yeah, let's go ahead and do this. So in case you've been curious about this is a question that we get a lot, that comes up a lot when we're talking about server-side Blazor, is people think about it really hard and they say, well, that probably can't work. Yeah. That probably is not going to have good performance. That probably is not possible. This is a comparison I made of the bandwidth of some of the things that you might use day to day. So I gathered this by using another code sample that I didn't show here, but I'm happy to show anybody later. I've got a form with like 5 text fields on it, and I'm just typing in those text fields and basically doing the kinds of things you do in an enterprise or line of business app. And the DOM updates, or the diffs that are getting sent across the wire per operation in that more complicated case, are more like 500 bytes. So if you think about, I'm entering things once a second on a form field, each of your connected clients in a Blazor server application is costing you 0.05 kilobits per second of bandwidth, compared to something like Spotify on desktop, which is using 160 kilobytes, or YouTube at its like worst resolution using like 1,000 kilobits.
Yeah. So in a world where video games can be streamed over the internet at 1080p or even 4K, as Google is saying, it ought not to be surprising that we can stream button clicks. It's not actually that hard.
Yeah. So if you want to understand or think about how to plan performance of a Blazor server application, the thing that actually matters is latency. So latency of more than 200 to 250 milliseconds feels bad. It will start to feel laggy if you're more than that amount. Fortunately, it's relatively easy to get latency better than that, but if your application involves devices that are going to have unreliable network connections or network connections with a lot of packet loss, Blazor server is not a good choice for that. Blazor client is a great choice. However, most of our use cases involve like being in our office, having a good internet connection, being close to the data center, or some little app that like 10 people are going to use. The latency and the impact of the DOM updates is going to depend on the kind of interaction. So if you intend to build an application that's got a big text field on it, and you're going to type your diary of everything that happened in your life in there, it's going to be 30 megabytes. The performance of that is going to be very poor, because that's something that has to be sent back and forth over the wire time and time again. But for the kinds of applications that people typically build and use inside businesses, the size of the DOM updates is not a very big factor. You can design to make smaller updates, but that's more of a consideration for people writing complicated controls like forms or tables or filtering grids. However, the performance consideration that does matter is memory. So because every connected client reserves some amount of memory and has their components in memory on the server, the amount of memory that your components use in your app and the amount of memory that the framework uses is a consideration that you have to care a lot about. So we did an experiment. We did some experiments with this before we shipped Blazor. We did this really cool thing where we wrote a headless client for testing Blazor. I'm not going to get incredibly deep with it, but basically we needed something that we could test Blazor better than something like Selenium, which is slow and heavy. So we wrote a client that uses SignalR to talk to Blazor directly and basically simulates a client, so that we could run lots of them. And we did an experiment on Azure. So a small VM for us, a D1 V2, which is like a single core small VM, gracefully handled 5,000 concurrent clients. So that's 5,000 clients doing a very simple forms thing with no degradation in latency. It was once we got significantly higher than 5,000 clients that we started to see the latency spike. And that was mostly due to memory consumption and garbage collection pressure. Likewise, we tried a much more powerful VM, and we were able to very comfortably run 20,000 concurrent clients on that VM. So thanks. That's my bit. I'm going to hand things over to Steve.
All right.
Tech staff, if you want to help us out.
Excellent. Right, let's switch control. We'll do it afterwards, if you don't mind.
Yeah.
Right then. So we can turn the screen back on. Excellent. Right. So during my part of this talk, I want to tell you some slightly more advanced stuff about some things with authorization and authentication, which is an interesting topic that doesn't get a lot of coverage. Before we really get into showing you how to do stuff with it, I want to show you what we're going to give you out of the box when you create a new Blazor application from the project template today. You might have seen this, you might not. So when you create a Blazor Server application, you get the choice to use your trackball if you turn it on. You get to be able to choose what authentication method you want to use. So if you click on this button, you'll see that we've got a bunch of different options for you. We can let you use no authentication if you want to. You can use individual accounts, which are stored in a database inside your application. We also let you connect to various cloud-based user identity stores. And finally, we've got good old Windows authentication.
Steve, are these the same options as normal server-side ASP.NET Core?
They are, in fact, the same options. It's the same UI.
So if you have any options that you're using with server-side ASP.NET Core, we expect them to work with Blazor as well?
They will indeed work, yes, because there's nothing different when it comes to what's happening at runtime with making this work on the server. So I'm going to quickly show you what happens if we create the option to use individual user accounts stored inside the application. So when that project has created itself and restored its packages, I can start this up in a browser. And what we'll hopefully see is something that looks pretty familiar, like a normal standard Blazor project. You've probably seen this about 100 times by now. The thing about it that's slightly different to usual is that up here in the top right, you can see we've got these register and login links. So let's say I want to log in. Well, I actually have to register myself first because I don't have an account. And when I click that, you see it goes over into this slightly different looking UI. And this is supplied by a feature that's built into ASP.NET Core on the server. It's called Identity, and it provides both a UI for user management as well as the data store for it. And that's integrated with Blazor on the server there. So let's register myself. That's not really my email address, but it'll work well enough. And type in a password that's good enough for the password policy. When I first do that, because I'm the first ever person to use this site, it doesn't actually even have a database yet. So it's going to give me this error message saying that I need to create the database. That won't happen if you deploy to production, but it does when you're running locally. So I've created my database now, and then I'll hit continue or reload. And then hopefully, well, let's try that one more time. When it's finished creating the database, then it will let me in, and you'll see I am indeed logged in as that person. And of course, I can do things like log out. I could log back in. Let's give my username again. And we go. OK, so we've got a user database, and we've been able to keep track of who's logged in. And we could now start using the normal Blazor programming model to produce different UI depending on who's logged in and what kind of capabilities and powers they should have. OK, so that's what we've got built into the box. But what I think I would like to, for us to spend our time doing now is going to a much more advanced level and thinking about what would happen if we couldn't use this built-in system and we had to create something else like it ourselves. Maybe we want to create a really custom user experience around logging in that integrates with a different custom backend data store. Right, so what's the scenario for our application? I do love having sort of gimmicky scenarios for my demos. So here's the one that we're going to do here. It's a little application I've been working on called Mission Control. Not a lot of people know this, but as well as being a developer, on the weekends I operate a network of spies, and they mostly work around the New York, the central Manhattan area of New York.
That's actually in my country. Did you know that?
Oh, yeah, I know.
Okay.
I actually... Yeah,
I wasn't sure if you were confused.
No, we play quite an influential role in the operations of your country. OK, so obviously, as a spy master, I need to keep track of where all my spies are. So I've got this application here, which, for instance, lets me list where they all are, and I know what all their missions are that they're currently dealing with. And if I want a slightly more graphically rich view of it, I can go over onto this agent screen here, and I get this cool 3D map that I can kind of scroll around and see what they're all up to. I could zoom out and get an overview. So, for instance, here's Natalia. She's triggering the global banking crisis.
That was a while ago, wasn't it?
Oh, no, this is the next one. We've been.
OK.
Yeah.
I look forward to that.
Yeah, everyone's been waiting for that for a while. We all want that, right? And then we've got, let's see, we've got Agent K doing some things with scuba equipment down there. OK, so this list of information about my agents is obviously very sensitive. I don't want it to fall into the wrong hands, so I want to protect it. The first and most important rule of any kind of security relating to client-side applications is that all of your security enforcement happens on the server. It does not happen in the client because nothing your client does can be trusted. People can always change the code that's in your client. They could more easily just look at what network requests it makes and then just modify all the IDs and the payloads of the requests if they want to. You just can't trust anything that the client will do. So if we want to lock this stuff down, we're going to have to do it on the server. So let's do that. I'm going to go into my server, and you can see I've got this MVC application here that is returning this hard-coded data, but in a real app, it could do something a little bit more interesting. And I'm going to use a very simple built-in feature of ASP.NET Core on the server to simply say that I want this controller to be authorized, which means that you can only access the methods on it if you are logged in. And I could add other criteria like roles and policies and stuff, but I don't really need that right now. I'm just going to do this. And then let's see what happens now. If I come back to my browser and try to reload now, then instead of getting this data, I don't get the data. I just get this kind of spinning thing that goes on forever, which is quite weird. But why is that happening? Well, we'll have a look, and we see that what's happening is the server is now responding with 401 unauthorized, which is good, right? That's exactly what we wanted. This user is not logged in, so they should not be allowed to see that data. But what's not so good is that this user experience is kind of insane right now. We're just showing this spinner going forever, and the user's just waiting and waiting. So what we would like to do is, if the user's not logged in, display a nice message to tell them why they can't see this data. And that's pretty easy to do, because in the same way that we use this authorize attribute on the server, we can use the exact same attribute in our client side or in our components that are running on Blazor, which is itself either running client-side in WebAssembly or server-side. It doesn't matter. You're producing this client-like experience, and we can use these same attributes on it. So I'm going to go to the thing that renders my list of agents here. And I'm not going to go through all the code here. If you want to learn more about Blazor's programming model and what these kind of components are and how you set up events and stuff, well, you can go and read some documentation about that. I just want to assume that we know some of that stuff and try building some UI inside it. So I'm going to add an attribute right here, which is the authorize attribute. And that's going to tell Blazor that I want people to only be able to go to this page if they're logged in. So if I reload now, then instead of seeing that scrolly thing, I now get this nice message: only logged in mission commanders may access this area. Now, you will be reassured to know that's not the built-in default message in our system. That's something that I've customized. And if you're wondering where I customized that, it's right here in my root component. So if you've not seen Blazor's router before, this is usually kept at more or less the top level of in your application. And it's responsible for knowing what the current URL is and observing when that URL changes and then displaying different pages depending on that. And we can say things like, if there is a page, or if there isn't a page, we'll display this message. If there is, then we'll do this other stuff. And the other stuff that I want to do here is use this thing called authorize root view. And that's built in. And what that does is it checks whether or not the page that corresponds to your URL, whether you can satisfy the authorization criteria for it. And if you can't, obviously it displays this message. OK, right. So I want to be able to do some real authorization now and some real logging in and such. But the question we have to ask ourselves is, what does it even mean to log in? What is our authentication protocol? Well, let's imagine that we've been given a protocol that we have to integrate with. We don't control this protocol. Someone else has done it. We've just got to build a UI for it. And the protocol that we're going to have looks a bit like this. OK, so we're going to have our client-side Blazor application. And in order to authenticate itself with a server, it's going to have to send a request to the server with a username and password. And what we expect the server to send us back, in this case, is going to be a JSON web token. That's a pretty standard thing within the industry. There are various different flows you can use for controlling how the client gets the tokens from the server. The one I'm going to do here is a bit like a password grant flow. But there's quite a lot of subtleties to it. And if you want to learn more, you can go and read some docs from the OAuth group or other people, and they'll tell you about how this sort of thing is supposed to work. But we're going to have a pretty simple implementation right here that gets that token. And then when we want to access some protected resources, such as our list of agents, we'll send that token inside the request to the server as a bearer header. And if the server likes the token that we've sent, then it's going to be willing to send back this protected data to us. Okay, so how can we get into a situation where we've got the token? Well, we need to make the user log in. Right then. First thing I want to do as part of logging in is actually show what the user's login status is. At the moment, I'm just displaying this hard-coded message. Let's see where that comes from, shall we? Inside my list of components here, I've got one called login display, and as you can see, it's just got this hard-coded message inside it. Now, what I want to do is display a different bit of output depending on whether the user's logged in or not. And I can do that using this built-in thing called authorize view. Don't know why the scale's changed, okay? And the authorize view lets us produce different outputs. So if the user's authorized, we're going to display hello, and we'll say their name. And if they're not, then we're going to just tell them that they're logged out. Okay, let's see if that actually works. I am logged out at the moment, so when I reload, hopefully, it will now say you're logged out. Good, that's working. We're happy with that. Quick question, though. How does the client know whether we're logged in or not? Just where does it get that information from? Is it asking the server? Does it somehow just magically know? Well, let me show you. The thing that determines whether you're logged in or logged out, or what your authentication state is, as far as the client is concerned, is a DI service, a dependency injection service. And we've got a built-in implementation of this, the authentication state provider, if you're using server-side Blazor. But if you're using Blazor on WebAssembly, which I am here, then there is no built-in implementation, because what does it mean to be logged in or logged out? You need to define a definition for that. So I've created an implementation of this called Token Authentication State Provider, because we're going to be working with JSON Web Tokens in a bit. And the implementation for that isn't very much. All it's doing is it's overriding this method called getAuthenticationStateAsync, and we're hard-coding the idea that we're logged out. So here's a claims identity, which is a standard concept in .NET. It's been forever. And that describes information about the user. And an empty one like this just means someone who's logged out. So that's my default hard-coded status. I'm logged out. If I wanted to, I could change this to hard-code the idea that I'm logged in instead. So let me do that just to show you what this will do. I'm going to create a different claims identity that hard-codes the idea that my name is Steve, and I've already been authenticated using this fake auth type, which is not a real thing. I've just made it up. But that's what my client-side application is now going to believe is the case for this user. So if I go back and I reload now, then instead of you're logged out, it now says, hello, Steve, which is quite a good improvement. Okay? So does that mean we can now fetch the list of agents from the server? Let's find out. I'll try to do that. And the answer is no. We still, despite the client thinking that we're logged in, we still can't get that data. And the server is still responding with 401 unauthorized. Just because the client thinks we're logged in, that is not going to convince the server. We still didn't provide a valid token. Okay? So let's try and get a valid token. I'll remove that thing about being logged in as Steve. I'll just go back to where we were before. So it says I'm logged out again. And now I want to change this up here so that it displays a button for logging in. So I'm going to go back to my, what is it now? My login display. And I'm going to change what we've got there a little bit to have a little bit more stuff going on. All right, so now, if you're authorized, again, we'll display your username. And if you're not authorized, we're going to display a message that a button that says login. And if you're wondering what all these MDC things are, well, this is coming from a NuGet package that I've installed, and that's what's providing all this attractive UI that has this material design style, and this MDC stands for Material Design Components. So that's coming from an external package, in case you were wondering. But anyway, that's how I'm going to display a login button. You might also be wondering what this thing is, a login dialog. Is that something that's built into Blazor? The answer is no, it's not. That's one of my components that I've defined in my application right here. So let me show you what that's going to do when that renders. Hopefully now we're going to see this button to log in up in the top right. And when I click on that, it's going to display this attractive login dialog, which has got some nice features in it, such as some validation. So if I click this, you'll see it says, you know, you didn't fill that out. What are you doing? And I'll start trying to fill this in, and you'll see the status starts to change, and that's all very nice. So what's going to happen if I click on login? Shall we find out? What happens is we get an exception, not implemented exception, okay? So we've obviously not finished doing our job just yet. Let's go and see why we got that exception. In fact, what is inside this login dialog? Well, There is quite a lot of code in this, and I appreciate that it might seem a little overwhelming at first, but don't worry, I'll walk you through it. It's not that bad, really. So this form on the screen here is an example of a data entry process. And so I'm using Blazor's built-in forms and validation system, and that is based around this built-in component called edit form. That keeps track of an edit operation that is taking place, such as which fields are dirty, which fields have got validation messages associated with them, things like that. And we have to tell it which model object we want to validate when this form gets submitted. So I've got this credentials thing, and down here, that's what defined as an instance of login credentials, a custom type in my application. I'll show you that. You'll see it's not got very much going on. It's just got username and password, and I've got these validation attributes on it. So that's why validation rules were applied. And to edit an instance of login credentials, I'm using some form fields. So I've got a text field here that's bound to the username property on my model. I've also got a thing that will display any validation messages associated with that field. Then what else? We've got down here, we've got some buttons that are going to submit the form. And up at the top, we're saying that when the form is submitted, if all the validation rules are satisfied, then we'll call this method submit credentials. And that is defined down here. And that's the thing that was throwing the not implemented exception that we saw before. OK, so what do we need to do? Well, remember the protocol. We want to send our credentials to the backend server, and it's going to return a JSON Web Token to us if our credentials are good. So let me put in a little bit of implementation for that. I am going to use the HTTP client to post in JSON format to the server the login credentials, the credentials object there. So that will get JSON serialized. And let's just mark this as async. And the result that comes back from there is going to be an instance of login result. That is simply just the JSON Web Token if the server is happy with us. Then we'll check whether the server seems to be happy. In other words, is that token null or not? And if it's not, then we think, OK, good, we're logged in. I don't know what to do yet. All I'm going to do right now is just print that token to the console so that we can see it. Let's try it out, shall we? I'm going to, once again, try to log in. And I'm going to enter a bad password initially. So the server will reply with an empty token and will display that message to the user. And then if I change it to a good password, then that form will go away and will display this token here.
Everybody take a picture of that token.
Yeah. This is my secret token. Now, if you've not seen a JSON Web Token before, this is an industry standard thing. It's a way of encoding a bunch of claims about a user in an encrypted and signed way. So if you're wondering what's inside it, we've got three parts. We've got this first part up to that first dot. We've got another part that goes down to this next dot, and then there's a third part after it. And each one of those parts is some base 64 encoded data. So shall we have a look what's inside there? I'm going to go to this website called base64decode.org, which is awesome, because that's just what I want right now. And I'm going to paste that base 64 stuff in there, and then I'll click decode, and we'll see that what was inside it is this. So it contains some JSON, and we've got this claim called name, and it says that my name is Steve, and that this token is going to expire at a certain point in the future, and we've got some other information as well. Now, if you're thinking, that means I can easily make tokens that say that my name is anything I want, that's cool. You can't really, because the third part of this token, if I remember correctly, is a signature from the server. So when you send that back to the server, it will be able to validate that it really did issue this token, and it can check the expiry date and things like that. OK, so we've got our token. Now we want to actually use it in some way. I want to use that to update my authentication state as far as the client is concerned. And that means parsing the information out of this token and using it in our authentication state provider. OK, so I want to centralize all the stuff about using a token here in this token authentication state provider. So instead of printing this to the console, I want to just pass that on to my, my thing, whose name is too long to keep repeating. So I'm going to send that token over there. And in order to be able to do that, I better actually import or inject an instance of this into my component. So let me just drop another little bit of code up here. I'll inject one of these authentication state providers so that I can call this setTokenAsync method on it. But I haven't implemented this method yet, hence the red squiggly thing. Let's go over here. What are we going to do with this token? Well, the first thing I'm going to do is just store it in memory. So I'm going to define a field to hold it, just temporarily, in memory, and I'm going to store the value on there. And then I'm going to tell Blazor that the authentication state has changed. And so anything that depends on authentication state needs to refresh at this point. Okay? And then, instead of hard coding the idea that I'm always logged out, I want to parse stuff from that token and use that as the authentication state. So I'm saying, if the token is null or empty, then we'll behave as if you're logged out. But otherwise, I want to parse the claims out of that token. And that's pretty easy. It just means splitting it on the dots, doing a base 64 decode, and then parsing the JSON data that I just showed you before. And that then becomes my authentication state as far as the client is concerned. So now, when I log in, hopefully, it will actually display that in the UI. It says, hello, Steve, you're logged in. And that's pretty cool. And you see that the rest of the UI is also updated, and it's now trying to fetch the data from the server, which is still not working, but we'll get to that in a minute. We've got a couple of problems. The first problem is that because I've only stored this token temporarily in memory, as soon as I refresh my page, I instantly become logged out again because the token wasn't really stored anywhere. So where should we store this token? Well, a convenient place for a client-side application is the browser's local storage, and I can do that quite easily. This authentication state provider is a dependency injection service, so it can depend on other services too. And I'm going to make it depend on having a JavaScript runtime. And I can use that to make calls into JavaScript, for example, to store this token in the browser. So what I'm going to do is I'll get rid of my temporary in-memory store altogether. Won't have a double line break because Ryan gets mad.
Oh, James gets mad at me.
Oh, yeah, sorry, James.
He's over there.
Yeah. Yeah. And then instead of storing my token in that field, I'm going to call a method on JavaScript runtime. I'm going to say we're going to call the standard JavaScript API local storage.setItem. The key will be auth token, and the value will be the token itself. And then when I want to know what the value of that token is, I'm going to read it back from JavaScript as well. And that's just as easy. We make a call on JS runtime to say local storage get item using the key auth token. So now, hopefully, that will be stored persistently in the browser. Let's see. I'm going to log in again. And then I'm going to refresh once again. And this time, I stay logged in. I know you can't really see anything happen, but really, I did refresh. There we go. In fact, I've done something crazy here. Anyway, right, it did work, and I'm still logged in. That's good. But sadly, I'm now trapped forever. I can't log out because I haven't implemented logout. Let's do a quick logout feature, shall we? On our login dialog, we've got a button click handler for logout, which throws at the moment. And I'm simply going to tell it that I want it to overwrite the current token with an empty string, and that will be sufficient to make me get logged out, as long as I mark that as async. Thank you. Right, let's see if I can log myself out now. So I'm still logged in, I click the button, and I'm logged out. Brilliant. And the rest of the UI automatically updated. All right, so we're very nearly there now. What's not working yet? Let's find out. I'm going to try once again to log in and get my data. And you'll see that I still don't get my data. And if we look at the browser console, you'll see still, unbelievably, despite all the hard work we've done, the server is still not happy. It still says 401 unauthorized. Why is that? Because we are still not sending the token in our request to the server. So let's do that now we've got the token. First, I'm going to have to be able to expose that token to other code in my application. So I'm going to do a little bit refactoring using this extract method tool here. I'm going to extract a method called getTokenAsync, like that. And then I'm going to mark that as public so I can use it elsewhere in my application. And then over on one of the places where I want to get some data, I'll be able to call it. So let's go to, inside my pages, I'll go to my agents list. And you can see I'm already injecting my token provider in here. So now I can get that token from my provider using the getTokenAsync method. And then when we make this outbound HTTP request, I'm going to also add an authentication header called bearer with this token value. All right. Let's see if finally we can actually fetch our super secret data from the server now that we're logged in. And we can. So finally, the server accepts that we're logged in. And all the other stuff is going to work. So if I hit log out, instantly it's going to switch over to this mode. It didn't have to reload the page. It just does it. If I log in again, then my data is going to come back, and all the authentication decisions are still being made on the client, on the server, obviously. Okay, so that is the flow that I wanted to show you. I hope that gives you a sense of how you could create a custom UI flow corresponding to whatever kind of back-end authentication service you might need. So that's enough about that. Now we've got a little bit of time left, and we had an idea for what we could do. We're just going to switch back to the other laptop, if that's all right. Is that OK? Right. There you go.
Perfect.
OK.
OK, great. So we've got a couple minutes for Q&A. We'll probably be hanging around afterwards at the party a little bit, too, if you want to talk to us. But shout out your questions. I have pre-canned ones that people can either upvote by asking, or if nobody has questions, we'll just talk about this stuff.
What do you want to know? Yeah, OK, so the question is about the performance of the diffing algorithm and how it might compare to other frameworks. Yes, so we've thought about this very carefully. It's been one of the first things that we started with when we worked on Blazor in the first place. And the good news is that because of the way that our system works, we have got an unfair advantage that allows us to be significantly faster than other things. And the unfair advantage that we've got is that we've got a compile step going on. And so you remember those sequence numbers that Ryan showed you on his slide? Those are inserted automatically by the compiler. And that gives us a lot of extra information that we can use at runtime during diffing. So when we do diffing over your tree structure, we can do it in an order n time. It's a purely linear operation to do that diff, which is ridiculously fast compared with a typical tree diffing algorithm, which can be anything from n squared to n to the 4th power, depending on what kind of operations you support. So yes, we have it very easy to do those diffs. And in most cases, we're going to be able to significantly outperform most things when you can count it based on number of operations performed, that is.
I'm wondering if you have any idea of what the adoption roadmap looks like for WebAssembly in mobile browsers, or if Blazor Server is the kind of solution for that in the foreseeable future.
Sure. OK, the question is about the adoption level of WebAssembly in browsers, particularly mobile. And the answer to that is that WebAssembly has been supported in the two main mobile platforms, iOS and Android, for a long time by now. I think it was first in iOS version 11, which is quite a while ago. And it's been in Android for even longer. So it's basically very, very widely available, more or less universal. As for the question of whether Blazor Server is a better fit for doing things on mobiles, well, it really depends. The key advantages that Blazor Server is going to have is more to do with the bandwidth required for getting that initial page to show up. So Blazor Server involves transferring a lot less data over the network to start up, and it's also taking the load off the client when it comes to actually running all the UI update operations and diffing and stuff. So Blazor Server can perform better on low-end mobile devices if they've got a good network connection.
So Blazor Server memory usage, what happens if you scale, and have you done any REST case, have you used offsite caches outside of it?
Great question. Do you want to take it, Ryan?
Sure. So the question was about scaling and about whether or not Blazor has any built-in mechanisms for scaling your memory or sort of sharing storage using offloading a store like Redis. So the reason why we don't have something like that is we don't have something like that because the thing that we have in memory is your instances of components. So it's not a prescriptive data structure kind of thing. We haven't found the need to do that because we're just basically using sticky sessions at the load balancer. So like the SignalR service does stickiness, and you're connected. So like there's no need to necessarily like move you to another node while you're connected. Does that address your question, or? Yeah, it's gone. So you can use other mechanisms for that. You could use Redis inside of your app for the things that you want to save as well. And we've got some docs and guidance on that. Down front.
Is it possible to use Blazor client and a non-Blazor server while using WebSockets?
OK, the question is, can you use Blazor client with a non.NET server? Was it a non-Blazor? OK, so to clarify, when you use Blazor client, what you're serving to the browser is just static files as far as the server is concerned. It does not matter at all what is on the server. You don't need it to be have any knowledge of Blazor. You don't even need it to be a .NET server. You could serve it from a Node.js server. I showed a demo yesterday of serving a Blazor client application from GitHub Pages. It's completely uninteresting to the server what the content is. It's just static files.
In the back.
The scenario you're describing where an outbound HTTP request is blocking things is very unfamiliar to me because you can't do blocking HTTP requests in the client, even if you want to. The only kind of HTTP requests you can do are asynchronous. So I think something different must have been happening in your situation, but I can't really guess what it is. If you want, come and chat to us afterwards, and we'll try and help you figure that out.
Okay, we're about at time, so we'll take one more. Down in front.
Sorry, the question again?
Threading.
Oh, multi-threading in WebAssembly. Yeah, sure. OK. So the question is, what's the state of multi-threading support in WebAssembly? Great question. So when the first version of WebAssembly came out, it did not have any kind of concept of multi-threading. It was a purely single-threaded specification. And that's the thing that is currently rolled out into like all the browsers in the world. As for adding actual threading support, there is a proposal for how that should work, and it's at quite an advanced stage already. So advanced, in fact, that it's already been shipped inside Chrome. Google has been pushing that along quite well. So I don't know how quickly that's going to come to other browsers, but it's obviously making its way along quite well. As for support within Blazor, that's not something we've started taking advantage of yet. The Mono team, who provides the Mono WebAssembly runtime for us, they've been working quite hard on making sure that they can attach .NET's concept of threading onto the new WebAssembly threading, and apparently that works really well, but we haven't started trying to use it yet. In terms of how it affects you as a developer, the programming model that we've designed so far is all designed around the traditional single-threaded model that most client-side developers are familiar with. So there isn't really much of a need for having multiple threads concurrently if you're just doing a bunch of things with button clicks and HTTP requests and stuff. The scenario you might want it is in more advanced scenarios where you're doing some kind of background computation that absolutely can't be interrupted for some reason. And for that, you would have to find a way of modeling that with asynchrony today. But we do expect to get the multi-threading support from Mono WebAssembly over the next coming months.
OK, thanks.